Hello everyone. Today we are going to discuss and solve problem number 12 from NeetCode 150, which is to three sum. So let's jump into the problem. So this is the agenda of the today's session. Understand the problem statement, walk through the examples, discuss and code the brute force approach, and discuss the time and space complexity of the brute force approach. Then we'll discuss the optimal approach. We'll discuss and code the optimal approach. We'll discuss the time and space complexity of the optimal approach. So let's understand the problem statement. Given an integer array nums, return all triplets, nums of I, nums of j, nums of k, array of nums of I, nums of j, nums of k, such that I is not equal to j, I is not equal to k, and j is not equal to k. Means I, j, k are completely unique, and nums of I plus nums of j plus nums of k equal to 0. This is the two conditions. So we need to form triplets, array list, collections of triplets in such a way that all the triplets satisfying these two conditions mentioned. Right? Notice that the solution set must not contain duplicate triplets. Since the input array will have the duplicate elements, we should not return the duplicate triplets, right? We should return only unique triplets. So this is the constraint. So 3, let's check out the constraint. So num length starts from 3 to 3000 and nums of I lies in between minus 10 power 5 to 10 power 5. Let's walk through the examples. So let me take these examples. So in this input nums array contains this elements, right? So if I take minus 1 0 plus 1, I'll be getting the sum as 0, and also these are completely unique. And also if I take minus 1 plus 2 numbers, this is also gives me three different numbers, three different indices, and the summation of it is 0, right? Basically choosing three different number sets in such a way that their sum is equal to 0, right? How can I able to do this process? How can I able to perform? So I can basically, the brute force approach that we can think is, what if I can try all the possible, what if I can check all the possible thing to figure out to find the answer. That's correct, right? So checking all the possible triplets against the condition that is mentioned here, right? So if that particular triplet is satisfying this condition, we will keep that particular triplet in our answer set, right? So brute force approach is basically checking all the triplets to find the answer. So this is the brute force approach code. See, let n is equal to nums dot length. I'm keeping this set to keep only unique triplets. So this 3 loops I have written. This 3 loop is returned to check all the possible triplets, right? So if nums of I plus nums of j plus nums of k equal to 0, this means that okay, this is satisfying the condition that is mentioned in the problem statement. So we will be preparing this in 3 numbers to make up the answer, right? Finally, I'm sorting this collections list sub answer, and I'm adding that into the unique triplets. Finally, I'm iterating this unique triplets to prepare the final list answer. I'll be returning that thing. So what is the time and space complexity of this approach? The time complexity is order of n cube and space complexity is order of 1. So at the maximum, nums dot length will be 3000. In that case, our algorithm will execute 3000 into 3000 into 3000, which will be 18 into 10 power 9. Sorry, not 18, it should be 27. 27 times 27 into 10 power 9, right? So 369, correct. So this will definitely give TLE error, right? We will need to think of the optimal approach in which we could reduce the time efficiency. Like we could improve the time efficiency. So we will be getting the time limit exceeded error. Yes. So the brute force, so the optimal, this is the brute force, and this optimal approach, what we can you what we can do is, if I have the sorted array, then I can think of using binary search or two pointers approach to figure out my answer, right? So first what we will be doing, let me take this example input to discuss this optimal approach using two pointers. That is what we are going to discuss today. This is the example input. So if, so first I will be sorting this particular array, then only I can use apply two pointer approach on that array, right? So -4 -1 comma -1 comma 0 comma 1 comma 2. So this is the input array. So let me present this screen to discuss this brute force approach, sorry, optimal approach using two pointers. Okay, so let's say I will be, first I will be at my index 0, right? So index 0, I will be at this particular point, minus, I'll be at this point -4. So, and then this is, and then I will be placing the left pointer here and then the right pointer here. This is my right pointer, sorry for, so this will be my right pointer, right? So what I will be getting is -4, sorry, let me change this color. So -4 plus -1 plus 2 gives us -3. This is not, this is less than 0. For that, since it is lesser than 0, moving the left pointer will open a path to get my answer, to get the number that I'm looking for, right? So I will be moving this left pointer now. Moving this way, I can, moving like this will may give the answer that I'm looking, right? So here also I will be getting the same thing, right? -3 less than 0. So again I will need to move the left pointer. Then I will move my left pointer at this place. Sorry, this will be my left pointer. So in that case, so -4 plus 0 plus 2 gives us -2, which is also less than 0. So again I will need to move the left pointer, right? Again I'll need to move the left pointer. So left pointer is at this place. So now, so -4 plus 1 plus 2 gives us -1. Again this is less than 0, right? We'll need to move the left pointer. So this is the breaking termination point. See, left pointer should be less than right pointer, but this is equal to equal, right? So the particular the loop will be terminated at this point, right? Okay, so this is one possible thing. Let's also, what if, so this is when I am at -4. So when I am at, okay, so when I am at oh my god, I'm really sorry for this. Okay, fine. So when I am at -1, right, I will be placing the left pointer here and the right pointer here. So at this point, if I add -4 plus, -1, right, I'm at -1, the current index is -1. So then I'll be adding -1 plus 2 gives us 0. This is equal to 0. So since this is satisfying the condition that I have, that's why I will keep this particular in my answer set. Let's assume this is my answer set. This is my answer set, and I'll keep this -1 comma 1 -1 comma 2, right? Okay, fine. So okay, here it's not that I can terminate at this point, right? What if I have some I it maybe I might have some different combinations I could. So I cannot terminate at this point, because if I move this left pointer towards, like, if I move this left pointer, I might get the different possible triplets that satisfies the condition, right? So I should not terminate this point. So what I will need to do is, what we will be doing is, basically, if you, so what if so that if suppose I will need to move this left pointer, basically, right? So I will need to move this left pointer, basically. So this left pointer to this place, and I will also need to move this right pointer to this place. That's it. We should do this. We should move the pointers, 2 pointers, right? That is what we are doing. So in this case, what will happen is, -1 plus 0 plus 1 gives us 0. Again, this is satisfying the condition that is mentioned in the problem statement. So again, I'll be keeping this particular triplets into my answer set, -1 comma 0 comma 1. So basically this is our answer set. Okay, fine. So this is the approach. Like, we will be iterating the whole array, and at every element we will be applying the 2-pointer approach, right? When we encounter a triplet, we are moving both the left and right pointer, right? In that case, we need to, it's not that I can use, okay, left pointer plus right pointer minus. Since it contains duplicate elements, what I will need to do, I will, suppose, let's suppose, so this is done, but let me also tell you one more scenario. Like, so, 1 second. So when I am at -1, right, when I am at -1, sorry, my god. Okay, so here, what I'm going to do here, I'm going to add, what if, suppose, assume that my input array contains something like this. So in that case, when I am at -1, I will be placing the left pointer here first, and then I will be placing the right pointer here. Since this is giving me the, since this is satisfying the condition that is mentioned, sorry for this, since this is mentioned, this is satisfying like -1 plus -1 plus 2, satisfying the condition that is mentioned in the problem statement. This is a valid triplet. I am keeping that particular triplet into my answer set. Then what we will need to do, we will need to move the left and right pointer. So it's, so again, if I move left pointer by one step, again this is, so what I'm, if I move the left pointer one step, right, so like this will be my right pointer. Sorry, oh my god, better to write it. So what if I move like this, right pointer? Again it's a kind of repetitive thing, right? Again this will be satisfying the condition, but this triplet is already formed, right? This is a kind of repetitive thing that we can avoid. What we will need to do in that case, we will need to place the left pointer straightly into this particular place, and we will need to place the right pointer straightly into this particular place to avoid the repetitive thing. And also we need a unique triplet, right, not duplicate thing. So that's why we will need to do the multiple pointer movement. If suppose, so I hope this 2-pointer approach is clear. Let me code this approach quickly. Let's discuss the coding implementation of this. So int left pointer equal to 0 and int right pointer equal to 0. So left pointer equal to I plus 1 and right pointer is equal to n minus 1, while left pointer is less than right pointer will be this condition. So int sum is equal to nums of I plus nums of left pointer plus nums of right pointer. If sum is less than 0, then we will be moving the left pointer one step. Else if sum is greater than 0, first we should not forget to sort the input array. If it is greater than, we will be moving the right pointer minus minus. If it is equal to 0, this means that this is the triplet. This is the valid triplet, right? This is the valid triplet. So I will be keeping this triplet into my answer set. Okay, fine. What about pointer movement? Okay, we should not miss to add this into our unique triplets, hash set. Once this is done, we will be moving the left and right pointer. What we will be doing, int temp element, current element. Sorry, temporary element, not current element. Temporary element is equal to nums of left pointer, while nums of left pointer equal to temp element, we are moving the left pointer. While loop I have written, right? So then again temp element is equal to nums of right pointer, and while nums of right pointer equal to temp element, right pointer minus minus. That's it. This should work as expected. Let's run this. Okay, what will I need to do in this case is left pointer is less than right pointer. In that case, this needs to be performed. Here also right pointer here also left pointer is less than right pointer, and right pointer is greater than or equal to 0. Okay, this condition is also not needed. It's an unnecessary extra condition. Okay, so the time complexity of this approach is order of n square. Order of n square plus this will take n log n time, right? This will take n log n time. So this is the optimal approach. The time complexity will be order of n log n, not order of, so it will be n log n plus n power 2, right? Finally we will be describing n power 2 is the time complexity, and space complexity is order of 1. Hope this should work. So this particular full code will take n square time complexity. Let's submit this. Yes, that's it. Thank you so much for watching. I hope this will useful. Thank you again.